Hey everyone, can you build a functional science web application without being an expert in the field or a pro coder? Today I put Google's most intelligent AI model, Gemini 2.5 Pro, to test whether I can build a chemistry AI agent based web application that can balance the chemical equation, visualize the molecules, and generate the PDF reports. Starting with a zero chemistry knowledge and relying almost entirely on a Gemini for the code and the debugging until it gets into the fully working application. Today, I'm going to explain this entire process. As you can see on my screen, this is the prompt which I created. Though it is very detailed, and again, I took a help from the AI tool only. So if you just read through this, it is actually explaining how that reaction balancer and the molecule visualizer AI agent should work. And then when I requested this, this is the thought process with Gemini 2.5 Pro put together. And before we continue, I'm using a Google AI Studio because that is where this model is accessible very easily, right? So if you just understand the reasoning which this model is utilizing, it's really awesome. It is breaking down the entire request, understanding the core requirement. It is trying to understand the core requirement, choosing right tools, chemical information, like whatever the subject on which the application is required to be built. Equation balancing, you can just read through the entire request breakdown, like molecule visualization, PDF generator, web frame, design, and a workflow. See how powerful it is, right? You can just take this entire thing. If you just go through, you can understand, the entire application design, architecture, the technical components and everything with this thought process, which is really awesome. And then I just got the setup information and the actual code, but this code was just running through the command line, right? And then since I need a web application, then what I did is I just asked a follow-up question. Could you please convert this solution into the web application with the FastAPI Python library, where some specific thing like index.html in the one folder, the style.cs and the script.js should be in a different folder. It's pretty standard. Then again, if you just see the thought, it just gave you the very detailed thought process, which is used by this model, which is really awesome, right? And then it's provided the project structure in which I want code. And as I just copy, you can see here, this is the same structure which we have. We have templates, we are index.html, then we have a static folder where we have a CSS related stuff, JavaScript related stuff. This is the report folder, and this is the molecule images where the images are going to be used. And then we have a chemistry agent logic, right? And then we have a main.py, right? So we can just understand all these things. We have the entire structure here, right? And we have the entire code as well. So we don't have to do anything, right? But the problem which I was facing when I just ran all these things, I just get into a lot of issues, which I asked this tool to help me with. And this is really awesome. And it helped me a lot with a lot of things, right? So this is real power. This is really the power of this Gemini 2.5. Now, once you run this, right, all I did is I just copy pasted the code in my PyCharm with this structure, come here and just run the simple command through which I can have the server up and running with UVCon, right? So when I run this, my application is available on port 8000, right? You can see on my screen, this is the first use case. So let me refresh it. Now, this is what the chemistry reaction analyzer. And if I ask, balance the reaction between aluminum and the hydrochloric acid to produce aluminum chloride and the hydrogen gas. Let's see what happens. If I just come back to the server, here you can see the complete flow, how the things are getting in here, right? So we can check here. Where is our request? Right, so we can see from here, received problem. This is the place where the problem is being accepted by the system. Balance, this is the question we asked. It is just going to the LLM to pass the request, and it just passed the information like, what all elements are required, the lot of internal component which is built by this solution, right? If you just come here in chemistry agent, then you can understand the kind of, components being utilized here, right? So ChemPy, Red, RDKit and all those stuff, which is really helpful libraries for chemistry related stuff. I hope that should have done. Okay, so now it's done. Report is generated. This is the balanced equation. So we need two elements of aluminum and 6 molecules of HCl. This really a little bit of, we used to hear this HCl. So this is something which we can fix. And then we have a report created. So I just downloaded it and this is the report. So now we can see the input problem. This is the problem which we have asked. And then this report is just got created by our code, and this is where the LLM actually just disintegrated what all elements we need, like aluminum, hydrochloric acid, what precise. So these are the two reactants. So you can see it just parts that it's reactant, and these are the two products which we need. We need aluminum chloride and a hydrogen gas, and just it got formulas and everything, right? Then this is the balanced equation, and then the reaction classification, type double replacement meta thesis, but it's not. If you just read the explanation, the initial identification of this reaction is double replacement. Metathesis is incorrect. While the double replacement reaction involve ion switching places, this reaction is actually a single replacement. So it's not a double replacement, right? Now we can see the molecules visualization, aluminum, HCl. Okay, this really looks awesome. Now, then what I did is I asked, could you please share me some test cases through which I can verify this application? And I got a lot of, like, this is the first one. Then we have some other use cases as well, which we can use. So, and input problems, balance the combustion of methane. We can request this one. We can come to our application. Here, analyze request, reaction. We can go back to the server. Okay, so we can see the problem received, balance the combustion of methane, start, LLM came into the picture, dissected, extracted all the element which is needed. Combustion means we have to utilize the oxygen. So this is the power of LLM. We haven't provided that we need oxygen, but that is where the LLM comes into the picture. It needs oxygen, then we can see the entire thing happened. So this is the equation we need. One molecule of methane and then 2 molecules of oxygen, which just produce water and carbon dioxide. We can click on download. Okay, so this is our report. Same input problem, identify the reactant and product. Combustion, this is really awesome. Now we need a classification, and then this is the reaction molecule visualization. Okay, so if we want, we can just try another one. Reaction of zinc metal with the copper sulfate solution. There we don't have any element given. Let's see what happens. Okay, so if we just click on this, we can come back here. Cool, isn't it? So this is really very powerful we have in our hand now, right? We can just build any kind of application which we want to build without even knowing much of that particular field, right? So if, without AI tools, if someone asks me to build this, so first what I have to do, I have to understand chemistry, right? And I have to understand the concept, and then it's unimaginable, how much time it's going to take for us to build this kind of simple application without having a AI tools, right? So this is what the balance equation look like. We have copper sulfate, right? It's a little bit of problematic. We can ask AI tools to fix that, like it should be CuSO4, zinc and copper will extract it, and then we're gonna get a zinc sulfate. So if I just click on the report, which really looks good, molecular 2D visualization, this is really awesome, right? Okay, cool. So that's it from my side. Now, what I want you to do is please start using this application, not application, all the AI models, right? This is just a power of Gemini 2.5 Pro experimental, with Gemini is saying it's the most intelligent AI model they have in their Gemini family. And I really agree with that. So what I'm saying is now we have this powerful tool in our hand where we can be more innovative and creative, right? And our innovation and creativity can be unlimited when you start using a AI tools. You won't imagine you can build anything, whatever you can think of. All you need is just a thinking, and you have to think a little broader, and you have to think a little bit in an innovative way or a creative way, like what you can build. So whatever problem you had, you can start asking for the problem solution with these AI tools. So that's it from my side. And you can also share in a comment section like what all AI tools you are using, what kind of product you are building, and what kind of help you are getting with that, so that the wider audience can also get aware of that. And if you want me to cover any other use case, or if you want me to share like how we can build another product, where we don't have any expertise from the functional standpoint or the technical standpoint, I can do that. Right. So thanks for watching this. And as always, stay healthy and keep learning a new thing. And if you really like this video, give me a thumbs up and share this video with your friends and your group. And as always, if you haven't subscribed for my video, please subscribe for my channel, and please subscribe that as well. Thanks for watching this once more.